So here's a quick little graph, right? Here's the fisherman, here's the boat, and here's due north. So here's the angle X. So it says, what's a reasonable domain? Now, the thing is, the boat is going west to east. So it's starting here and it's kind of going this way. And the fisherman's just chilling. So you imagine as it comes to the other side, it's going to go this way, this way, this way. Now, even if the boat is really, really far to the left, right? Let's say over here, even like this, that X value, you can tell, like, even if it's over here, the angle's never going to get beyond 90 degrees. And they're saying it's negative going this way, so negative 90. But in radians, that would be negative pi halves. And then as the boat goes to the right, now we're talking about positive angles, but even as it goes further and further, it's never going to go beyond 90. So again, in radians, that's pi halves. So I'd say a reasonable domain would be from negative pi halves to pi halves, not including those values, but up to those values, so hence the curved parentheses. Now we need to graph this on the domain, so let's go ahead and do that in Desmos. So here is the graph, right? Just like what we'd expect from secant, cosine the max would be here, and then we just kind of go up with that parabola. And there are the vertical asymptotes, and the vertical asymptotes I actually drew in. They're occurring at pi halves and negative pi halves. That makes sense. That's our domain, okay? So when we talk about the vertical asymptotes here, they're just the boundaries for, you know, what are acceptable angle values or what angle values we can actually get here. And the other thing to note is as we approach these asymptotes, as we get to 90 degrees or negative 90 degrees, in our case, pi halves or negative pi halves in radian, you can see that the distance goes off the chart. It approaches infinity. So that's kind of what it represents as well. Now to calculate the function value at negative pi thirds, we're going to plug it into Desmos. So here we get an answer of 3. So what that means is when the angle is at negative pi thirds, the distance of the boat to the fisherman is 3 kilometers, because it did say it's measured in kilometers over here. Now let's do d of pi 6. Let's do that in the Desmos as well. So here rounded to the nearest hundredth is 1.73. So we can say when x equals an angle of pi 6, that would be like somewhere over here. The distance would be 1.73 kilometers, okay? And then now we get to F. What is the minimum distance between the fisherman and the boat? When does this occur? So I think we remember from the graph that occurs when x equals 0. That's when it's right due north, okay? When the angle is 0 radians. And now let's find the minimum on the graph. And it's right here. It's a distance of 1.5 kilometers. So the minimum distance is 1.5 kilometers. And that's how you do it. Boom, done.